This is the video for section 11.6 day 2, secant-tangent angles. Please follow along with your video worksheet. The first section has all of the terms, definitions, and diagrams that I will be using, and the second section has all of the example problems that I will be showing you. Please fill in the worksheet as you watch the video. Let's begin. A secant-tangent angle is formed by a secant and a tangent to a circle. So if you look at our diagram here, this segment is a secant to the circle, while this one right here is a tangent to the circle. So this angle right here is what we call a secant-tangent angle. This type of angle will have its vertex outside of the circle. Now this is our table from yesterday. This is the table that relates the location of the vertex of the angle to the formula we use that relates the angle to the arcs. Now first, if the vertex of our angle is at the center of our circle, our formula is the measure of the angle equals the measure of the intercepted arc. If the vertex of the angle is on the circle, like an inscribed angle would be, or any other angle that has a vertex on the circle, the measure of the angle would be the measure of the intercepted arc divided by 2. If the vertex of the angle is inside the circle, the measure of the angle is equal to the measure of the angle's intercepted arc, which I call arc 1, plus the measure of its vertical angle's intercepted arc, which I call arc 2, divided by 2. If the vertex of the angle is outside the circle, the measure of the angle is equal to the big intercepted arc minus the little intercepted arc divided by 2. Here's our first example problem, and in this first example problem we are going to be reviewing different types of angles from earlier on in the chapter. So in example number 1 we have what's called a central angle, and it's called a central angle because its vertex is at the center of the circle. Whenever we have a central angle, its formula is the measure of the angle is equal to the measure of the intercepted arc. So in this case, this is our central angle. So the measure of the angle, which is x in this case, has measured the same as the measure of its intercepted arc, which is given as 84 degrees. So x is 84 degrees. Moving on to question 2. Now question 2 is not going to be a central angle because its vertex is not at the center of the circle. Question 2 is called an inscribed angle, and that's because the vertex is located on the circle. Now by tracing the two sides of the angle, we see that the vertex is at E, which is on the circle. So the formula for all angles that are located on the circle is angle equals measure of the intercepted arc divided by 2. Now because that's the case, the angle is smaller than the arc. So if I want to find the arc, I'm going to be multiplying the measure of that inscribed angle by 2. So I'm going to be taking 77 times 2, which is equal to 154 degrees. I'm going to label it on my picture as well as the answer blank. Next, I'm going to notice that the measure of angle EGD, which is right here, starting at E, going through G and ending up at D is going to be 180 degrees. And the reason I know that is because it's a semicircle. So I'm going to label it on my picture as well as my answer blank. Next, I'm asked for the measure of arc EF, which is right here. Now, if you notice that the yellow arc, the blue arc, and the purple arc together make the entire circle. So if I want to find the measure of arc EF, the purple arc, I'm going to take the entire circle, 360 degrees, minus my semicircle, 180 degrees, and then also minus my blue arc, 154 degrees. That leaves me 26 degrees for the purple arc, arc EF. Question 3. In question 3, my angle is formed by two chords. Whenever that happens, your vertex is going to be inside the circle. Whenever your vertex of your angle is inside the circle, the measurement of that angle is equal to the measure of arc 1, which is its intercepted arc, plus the measure of arc 2, which is its vertical angle's intercepted arc, divided by 2. So using that formula, our angle is x equals the measurement of arc 1 is going to be 2 degrees plus the measurement of arc 2 is 46 degrees divided by 2. So x equals 46 plus 2 is 48 divided by 2. So x is 24 degrees. Moving on to question 4. This angle is also formed by two chords. So its vertex is going to be inside the circle. So its formula again is angle equals arc 1 plus arc 2 divided by 2. But this one is set up a little bit different. The angle is 54 degrees. So I'm going to put that where it says angle equals arc 1, his intercepted arc, is 31 degrees, plus arc 2, his vertical angle's intercepted arc, is going to be x degrees, divided by 2. Now, in order to solve this algebra problem, we need to put the 54 over 1 and cross multiply. 54 times 2 is 108, equals 1 times 31 plus x is 31 plus x. Subtracting 31 from both sides gives x equals 77 degrees. Going on to question 5. In question 5, we have a secant and a tangent forming our angle. When that happens, our angle is going to be outside the circle. And the formula when the angle is outside the circle is angle equals big arc minus little arc divided by 2. So in this problem, our angle is x. Our big arc is going to be this one, which is 139 degrees, minus our little arc is going to be this one, 101 degrees, and divide by 2. Please don't forget to divide by 2 there. So x is 139 minus 101 is 38, and again divided by 2, 38 divided by 2 is 19 degrees. So x is 19 degrees. Now in question 6, our angle is formed by two secants. Whenever this happens, our angle is going to be outside the circle. Whenever our angle is outside the circle, we use the formula angle equals big arc minus little arc divided by 2. Now in this picture, our angle has measured 27 degrees, and our big arc is this one right here in blue. It has measured x. And our little arc over here in yellow has measured 36 degrees. And we divide by 2. Now in order to solve this problem, we need to put our 27 over 1, cross multiply, and we get 54 equals x minus 36. Adding 36 to both sides gives x equals 90 degrees. Now this problem also asks us to find y. Now in order to find y, we notice that it's given that this arc right here is 117 degrees. So if we take the blue arc, the purple arc, the yellow arc, and the arc that says y, those arcs together will add up to 360 degrees because it's a whole circle. So I take 360 minus 90 minus 117 minus 36, and that will give me y, which in this case is 117 degrees. Moving on to our last question for today, question 7. The location of our vertex is going to be outside of the circle. And this is because our angle is formed by two tangents. Whenever our vertex is outside the circle, our formula is angle equals big arc minus little arc divided by 2. Now we start by saying our angle is equal to x, and then we go to our big arc. Now our big arc goes from here all the way around to here. It's not given to us, which makes it kind of difficult. But what we do notice is that our little arc is the rest of the circle, and it has measured 148 degrees. And I'm going to divide by 2. Now in order to get that big blue arc, all I'm going to do is take 360, which is the whole circle, minus the 148, which is the yellow arc, and that will give me the measure of the blue arc, which is 212 degrees. Now they didn't ask me for the measure of that arc, but I really do need it in order to solve this problem. So that blue arc is 212 degrees. Simplifying, I get x equals 212 minus 148 is going to be 64 divided by 2, so x is 32 degrees. This concludes the video on section 11.6 day 2, secant tangent angles. Thanks for watching.